matter.
Dark matter.
We can see dark matter.
Degree of dark matter.
Dark matter.
The dark matter.
The dark matter.
Welcome to Dark Matter in the Pub.
And it's a very important one, actually one of the most important discoveries of the 20th century.
So has anyone heard of the term gravitational lensing?
So what if we find it? What's gonna happen then? And to be honest, I dread that question because what do I know?
Photons don't have mass, so is it possible that there could be another particle like the photon that does have a mass?
What if dark matter can kill you?
You to know that, all I need you to know is that axions are a really good dark matter candidate.
Once upon a time there was a fish, and this fish was very extraordinary because it could swim in the ocean without being seen. And the secret of this fish was special tissue in its skin and the scales, which had very special abilities. So you might know about polarized light, right? And the skin of this fish and the scales were able to detect tiny changes in polarized light and reflect the light in such a way that it camouflaged the fish.
So human beings are pretty good at figuring out things, right? Even if we can't see things. Like if you look at this picture, can anyone tell me what's going on? Exactly, the wind. But why do you say that? Like we just heard about all these particles, they're teeny tiny, we can't see. So why do you look at this picture and say, wind is blowing? Exactly. We can see it because we can see its effect on the trees, right? So even though we can't see air, we can see its effects on its environment. And dark matter is very similar. We can't see dark matter, but we can see its effect on its environment through gravity.
But just so we're on the same page, let's just list the things that we do know about dark matter already. So the first is that it's dark, that's in the name. And in astronomy, when we talk about dark things, we're talking about invisible things. So dark matter is a thing which doesn't emit light, and it's a thing which doesn't absorb light. The second thing we know is that we know very precisely how much dark matter there is in the universe. It's about 85% of the matter content of the universe. And this is a number that stays the same across time. It doesn't accumulate, it doesn't disappear. There's always that 85%. And then the third thing we know is that dark matter, whatever it was created in the first 3 minutes of cosmic history. So 3 minutes after the Big Bang, dark matter had to have been made and doing its thing.
Axions. Axions are very, 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 very small. So if the kind of dark matter people typically looked for is what we call the WIMP, axions are like 1,000,000 billion times smaller than those. Very, very little. To put that in perspective, if the kind of dark matter that people mostly look for was the Eiffel Tower, then an axion would be a single grain of sand or thereabouts, about 1,000,000 billion times lighter. Very, very little, which means that when we think about how we detect these things, we have to think about them a little bit differently.
There are 70 billion neutrinos going through every square centimetre. So make a hole with your finger that's about 1 square centimetre. Okay, ready? We're going to do that for a second. Ready, set, 1, 2, stop. Okay, in that time, 70 billion neutrinos went through that little hole.
So a few years ago, in 2020, a group of scientists had this idea. What if dark matter can kill you? Have you ever thought about that? Like maybe dark matter can kill you. And so what they did was write in this paper, death and serious injury from dark matter.
No, we don't care. We want to know, is it going to make my car go faster? Is it going to heat my house? And again, I don't know. But the good thing is that over many years in basic research, we have had technological applications. So it doesn't really matter what the basic science is about. The World Wide Web was actually invented at CERN by particle physicists trying to share information with other particle physicists at different institutions.